Hey all, April 26th here, looking at our next severe weather outbreak for spring of 2016, and we're starting out with a supercell coming together along the Kansas-Oklahoma border. That's going to be tracking up towards the Wellington area, possibly Wichita over the next hour or so. And we're still pretty early in the afternoon, and we've got another storm coming together near Lahoma, which is just southwest of Enid. And you can see our watch box that's going to bring it to the north. And let me see, I don't I don't have my John Madden overlay type thing, so I got to get that started. Okay, there we go. So yeah, that's going to put a track probably just north of Enid. I have just started looking at this just now because I want to immerse both you and me in a look at the weather as if we hadn't been tracking this all day, like we just got home from work, we're checking things out. That way we can kind of learn what's going on and start looking at some of the charts and have kind of an understanding of how this is coming together. So I don't even know the movement right now. I would have to animate this, and you can see GR2 brings this kind of a north-northeast direction, like that. But as they become more rooted in the boundary layer and become more focused in that layer, like from 0 to 1 kilometer as far as the inflow, then we'll start to see more deviant motion, maybe to the east-northeast. We'll have to look at photographs to know this for sure, but this is kind of what we can anticipate as this comes together. This is still very early in the life cycle of this storm. Definitely showing rotation here, but this could also start going some. My tongue is getting ahead of me here. We should start seeing some more east-northeast movement as these become more low-level based. So you see that motion right there. It's still about 040, and that would trend more towards 060 to 070. What do we have further down the line? Well, we've got some higher base stuff here, northwest of Weatherford, about maybe 15 miles. What's that doing? Not a whole lot. Looks like showers or turkey towers. This is up at about 9,300 feet where the beam intersects this, and at higher elevations see a little bit of 20 to 30 dBZs up at 15,000 feet or so, and that falls on off above 31,000 feet. So these look like some CBs trying to come together in this area here, but there's still a ways to go on that. We don't even know if that's going to come together. I'm adjusting my internet settings here so I'm not lagging things too much. YouTube likes to try to push a lot of stuff down the pipe, like it tries to start a playback to preview the live feed, and that just eats up my bandwidth, so I'm going to shut that off here. Okay. So to see what's going on further down the line, we really need to look at satellite. And to do that, we have to run, well, you can look at internet products. That's certainly a possibility. But for the maximum quality of satellite images, I like to use Mercatus. So I'm going to start that up. So I'm waiting for that to come up real quick. Okay, let me check my audio levels here. Everything looks good. Okay, we're just waiting for Mercatus to fire up here. Okay, the window is a little bit flaky, so sometimes you have to kind of move it around like that. See there? So I'm going to focus that on the area of interest. I'm not going to cover Kansas too much because I don't like covering too many areas at once. That's going to really distract us. I'm going to focus mostly on Wichita south to Oklahoma City to Dallas. Let me expand the window just a little bit. Well, I better leave it like that so we can see the whole thing in the video feed. So let me set this up. This is probably about what we want to look at for today, something like that. Alright, so that's the window. Let me actually move that a little bit further west, because we want to see what's coming down through the upper levels. We don't care too much about what's east of I-35 right now. Okay, for our sources, we're going to use Genie East with this atm.ucar.edu. We're going to connect and get a list of the different image types. We'll do the 1 kilometer viz, and with any luck, next spring we're going to have 0.5 kilometers, and that's going to really revolutionize things a little bit. We're going to have 4 times the resolution. I'm talking about half the resolution one way and half the other, so that'll give us 4 pixels for every pixel we're getting right now. Okay, most recent. Then I'm going to go to add source down here at the bottom. See it right there at the bottom, add source. That will retrieve some metadata for that image. So I'm going to go and click on this, go to, seems to not matter which one you pick as far as what I've been able to determine. So I'm going to click on raw. Then over here I'm going to go to advanced. I'm going to click this little icon right here and click center. So you can see that's centered 3599. That's just west of Oklahoma City. Then I'm going to knock this resolution up to 1. And I'm going to give us a little bit more vertical resolution. So I'm going to bring this up to 900. That way we get more of a portrait type appearance. This will bring in more data from the south and the north, so we can pan around and see what's happening up in Kansas and down in central Texas. Okay, once we're done with that, we're going to click Create Display, and that will start downloading the data. So you see that right there. So do we like the image that we have here? Does that go far? Yeah, that goes all the way up to I-70, all the way down to central Texas, almost to the hill country. That's pretty good. I don't want to make this too large because that's going to eat into the bandwidth and that's going to cause a little bit of lag on the video feed. So we're going to stick to this. Now we're going to zoom in. And maybe I'll adjust the color a little bit so you can see the... Let me think. Do we want to go with blue? Yeah, we'll go ahead and... I'll go ahead and stick with this for now. Okay, 20Z, that's going to be 3 p.m., so this is an image from 12 minutes ago. And there it is. We can see the storms. There's the storm southwest of Wellington. You can see that the anvil canopy is not very large. Extends maybe about 50 miles downstream, so this is a fairly new thunderstorm. And this storm near Lahoma and Enid is even newer. Anvil canopy basically covers maybe 1 county size. See a little bit of overshooting top there. In fact, let me zoom in and you can see that better. So you see that little overshooting top right there. If you lose radar, or if you're out in some part of the country where there's very poor radar coverage, like southeast Montana, you can use satellite to kind of get a handle on what's going on when you start seeing stronger overshooting tops, more ripples in the anvil. That tells you probably have a stronger updraft. So you see there's the updraft right there. There's probably a little bit of tilt in that, so you have to kind of keep that in mind. But anyway, there's the overshoot right there. So what's happening further down the line? Well, one problem is that we have a lot of cirrus moving across the area. See that right there? Let me pan that down. A little band of cirrus moving across the area, so that's kind of covering things up a little bit, making things kind of hard to see what's happening along probably what's the stry line. So a little bit of interference there. And panning further west, look at that. Look at this mess here. I can tell this is probably back behind the dry line. This is a pretty good chunk of upper level energy moving through the area. This is probably stronger than what we typically see in a situation like this. So this is probably high base stuff. I'm going to look at the surface chart and kind of figure that out. And then further south, looks like some high base storms there near Big Spring, west of or east of Odessa. And then further to the east, you can see the feed of moisture working northward right there. And we pick up a little bit of transverse banding around the Stephenville to Comanche area. So things still look pretty stable for the most part beneath the cap around I-35 and east of there. And then further west of there, we're covered up by the cirrus. So this is when we need to look at the surface charts. Since I'm expecting to do a lot of analysis today, I'm going to use digital atmosphere for this. So we'll get that started up right there. I'm going to pan this a little bit further north. So I'll get the map configured for today. Add overlay, counties, outline. Add highways. Then I'll lock that in with copy markings to base map. And then I'm going to load in the data using data and then data retrieve. So we should have the 3 p.m. data from College of DuPage. So we're going to download that real quick. I don't really know for sure how the video feed looks. If it doesn't look that great, I apologize. We're on a very narrow DSL connection here because I'm about 15 miles out in the country. I looked at getting symmetric DSL from Windstream, and they wanted like $400 to $500. So I don't really have that kind of budget to throw at this production, but you know, if we get some financial backers or something like that, we can certainly do that. But for right now, we're kind of limited to the DSL feed that I have here. All right, so let's see. We've got the surface data pulled in. I'm going to plot the data here. Let me get this aligned with the window. Okay, so here's what we got there in Oklahoma. Let me get this sized. Okay, there we go. So the first thing that I'm looking at right here is the dew points. That's going to be the marking in the lower left side. So we have some bad data here. We're going to throw out that plot. So I'm looking for consistency before I start really using this data here. So I can see 64 there at Abilene, 46 at Sweetwater, 40 there at Snyder, and then it looks like we have bad data right here. I'm going to erase that. Okay, now things look pretty good here. So dew points, we're going to kind of take an imaginary car drive from Fort Worth. That's located right here at the bottom. Looking at the wind field and dew point. So we've got southeast winds Dew points are around 67 there at Fort Worth, 66. A little more southerly winds, getting a little bit of veering there at Wichita Falls. Go further up the road, 63 there at Vernon. And then it falls off to 39 there at Childress. So that's probably where we hit the dry line. So I'm going to draw that on real quick. And then we'll bring that further north. So at first glance, this is where the dry line is. Running from about east of Alva to about Clinton to about Oklahoma Union, forgot what city is in there, between Vernon and Childress, and then on down to, see, that's going to be probably just west of Abilene, so we're looking at about Anson to Stamford. So that's our dry line location at 3 p.m. Now I also like to look at boundaries out in the moist sector. I can see if I can see anything here, and I don't. Looks pretty homogeneous, but there is this backing of wind. See in here? That's going to be in the Lawton area. Maybe a little bit more backing around the Bowie area down to like Henrietta to maybe Denton. So we're going to be kind of watching for maybe a mesolow. In fact, we might even have one with that backflow near Childress. Could be a mesolow down in this area. And you can see the dry line is kind of, got this S shape going on. So this is probably what's going on. We probably got a little bit of a mesolow around. This is going to be around, let's see, south of Childress. What's down there? I don't have my atlas here, so I'm going by memory. It's going to be north of Guthrie and south of Childress. It's going to be pretty much in there, whatever the name of that town is. Just east of the Caprock. Okay, then further west, we've got that big chunk of upper level energy. Remember those showers we saw on the satellite? In fact, let me bring that up here real quick. Look at that. It's probably pretty neat to see go through if you're in Amarillo or Plainview. Probably some really dark clouds there, showers, some very cold outflow, certainly. And we can kind of see that on the surface, and I think that's probably the cold front. I don't want to say that for sure because down around Carlsbad we've got 79, 76. Well, we're going into May, so yeah, that's probably post-cold frontal air. We got 67 there around west of Clovis, 50 at Klein's Corner. That's going to be post-frontal cold air, so this is going to be a cold front right in there. So dry line out ahead of it like that, mesolow south of Childress, and cold front coming into the Amarillo area and west of Lubbock. And the cold front is triggering that very strong high-based shower activity. And then we're watching for development along that dry line. So we could see continued development not only down to the Clinton Elk City area, but we could also see development west of Vernon, possibly down to Seymour. So we're going to keep an eye on that. See, we don't have that very well pinned down on the satellite imagery because of that high overcast. So we're kind of depending a little bit on the surface chart and the radar to see what's going on at the surface. So to kind of want to draw that on, this is kind of the area we're looking for. It looks like there might be some evidence of some towers southwest of Vernon. So we're going to want to check the Dias radar, maybe the Frederick radar, to see what's going on down there. And further west, there's the cold front. Now that we've done the surface chart, we know that that's the cold front moving through. So we're not expecting anything severe from that. We could get some strong gusty winds if there's enough dry air and train in that downdraft. What we'll really be watching for is stuff in western Oklahoma and northwest Texas. So at this point we should go back to the radar and keep tabs on what's going on. Looks like the Oklahoma storm has really come together. See that it's becoming a little bit stronger and more surface-based. So we're going to be watching for that to move towards Kremlin here. Could go up to Pond Creek, or it could even go to the northern part of Enid. So probably I would expect chasers to be getting in position in this area, or maybe on the farm to market roads. Well, they don't have that in Oklahoma, but you know, the grid roads northwest of Enid. Further up the line, looks like some disorganized stuff around Wakita. Looks like we already have a tornado warning now on the cell southwest of Wellington, Kansas. So there it is. You see the tornado warning. Sometimes I like to look at this and see what their basis is for issuing it. And what they're going for here is radar indication. So there's probably spotters on this, but they're probably not seeing anything at the surface. Probably just wall cloud type stuff. You can see a little bit of a slight HP-ish structure here. I'm not going to call that an HP, but it does have more of a kidney bean shape that we see with classic and the so-called LP storms. So there's the notch right there. Well, you know, I just noticed we're up at 5.1, so I kind of hosed that up. So let me go back down to 0.5. There we go. It still looks a little bit HP-ish even down there, so we're going to put that notch right there. We're going to watch for a rotation in this area. Do we have that? Well, here's the base velocity, and I haven't set the storm node velocity vector yet. I really need to do that. Don't see a whole lot of rotation, however, we're using the Enid radar. This is about 30 miles from the radar. Yeah, it should be capable of detecting any rotation in that storm, and I'm not seeing a whole lot right now. Let me set the motion vector, and remember we had some problem with this in the last video because I had trouble. They put everything on the shortcut toolbar, and I had to remember where that is. Let me show you where to find that. So here, set storm motion vector. When you're using level 2 products, you have to you have to come up with that yourself. But that's not too hard. We just estimate a vector 220 at 20, which should work well for this situation. And we're seeing a bias towards inbound velocities. So I may have that a little bit high. So you just want to kind of play with this to get something that's representative for that cell. So let me put in 10. So that brings up the outbounds a little bit. So we'll just go with that for now. So don't see a whole lot of low-level rotation, but of course we want to go down to the lower levels. Let me get this set up so you can see a little bit what I'm doing on the level selector over here on the right. There we go. It's probably a little bit better. Okay, so let's go up to a higher tilt. It's like around 2.4 we kind of lose that. We start to see more of a I don't know, I'm not sure I see a couplet in that. Whether it's rotation or shear, I don't really see that. But in the lower levels, I do see a little bit of weak rotation in here. Not really seeing that too well on the Enid radar. We may see that a little bit better on the Wichita Falls radar or Wichita radar, so we may look at that a little bit later. All right, where's our other cell? Let me pin that down. There it is. That's going to be about 10 miles north or west of Enid, around Lahoma. Storm relative velocity is also not showing much in the way of a strong couplet. This is still pretty early in the storm's life cycle, so it's normal not to see a whole lot on the radar this early, but it can, as it continues organizing, we should see those patterns start firming up. What I may do also is I may change the velocity tables to a different color scheme, and that'll help those stronger velocities stand out. I'll show you how to do that a little bit later. Okay, so things are still pretty early, still kind of disorganized. Radar indicated tornado warning on the stuff southwest of Wellington. That's probably from the Wichita radar. Probably showing a little bit better there. And further down the line, there's our higher base towers between Sealing and Watonga in Oklahoma. So that's still not come together quite yet. And further down the line, nothing until we get to the Crowell area. So this is getting near that mesolow. So let's look at the Frederick radar. In JR2, we can just click on that and it will start downloading the new products. So while you do that, I got to make a quick phone call, so let me do that. I'm going to mute the microphone and put up a little notice here. So okay, as far as the Frederick radar, it's still downloading products. You notice that we don't show that echo as well on the 0.5. The Enid radar is probably picking up higher based animal stuff, and you can definitely see that as we tilt up higher. See 5.1, this is up at about 25,000 feet. So this is either like a prolific turkey tower, it could be a storm just starting to come together because you see the higher precip levels in the mid parts of the storm, like up at 15 to 20,000 feet. It could be what's happening here because we're seeing very strong echoes. This is 52 dBz, so we're seeing the start of a storm coming together. So any chasers that went down to the Vernon, Red River area, they're going to be happy about that. Probably getting in a position right around here. So anyway, let me make that phone call. I'm going to take a break, and so I don't blow my voice out. I'll put a little message here. Let me see if I can get this set up. Okay, that's pretty cheap graphics there, but we'll just go with that for now. Let me get a good radar tilt set up where you can check some of this out. In fact, there's not much going on. Let me just put it on this cell right here. I'll pull up the advanced radar and just okay, I'll leave it like that, and I'll be back in about 10 minutes. Okay, guys, excuse me, I'm back here, and I was notified by a viewer that we were showing this stream as being April 11th. I guess YouTube reverted some of the titles back to the last one we did, so I'm going to go ahead and stop this stream, and please check back. I'm going to relaunch a new one, so this will help people find the streams better as we get into the afternoon. So once again, I'm going to relaunch the stream. So look for the Tim WXX page for a new stream starting up, and we will pick back up where we left off and see what's going on with the severe weather. This should be up in about 2 to 4, maybe 5 minutes, and we should be good to go. Okay, guys, we are live again. I should mention that a lot of the streaming is kind of experimental. I'm kind of trying to figure out this technology myself because I'm not like a gaming streamer. I don't do this like every day. We have to do this only when we have severe weather going on. And it's still pretty early in the season, so I'm kind of still figuring out a lot of this technology. And YouTube, they kind of change their interface a lot, and I have to keep track of all those changes, so it's kind of a mess sometimes, but we'll get it figured out here. Let's see, live stream is good, and hopefully it's showing April 26th now. That would be pretty confusing for anybody just now joining if it was different, but I think it's okay now. Anyway, look at this. Look at this outflow. This is an older cell that was in the Tulsa area earlier. So we got a little bit of dry air aloft, or maybe some shallow, low-level dry air with, or shallow, low-level moist air with dry air just above that. Either way, there's dry air being entrained either into the updraft or downdraft, so that's going to be a concern with these storms too. We'll have to keep an eye on that, just in case the same stuff is going on. Okay, as far as other storms, what's going on? Well, one thing is we have to update our satellite imagery because this is for 20Z. So let's do that right now. There's an easy way to do that using the Data Explorer. You just go to your field selector, right-click and go to Properties. You can do this automatic reload. We'll set it up to do that. We'll go to Apply. I don't know if it changes that right away. See, at the bottom it doesn't show any activity happening. So we can just go to Reload Data. And we'll check and make sure those properties took real quick. Yeah, so we're now active. It should be keeping that satellite data refreshed as we go through this. So now we're picking up the cell down around Childress, down around Quanah to Vernon. And it looks like another little turkey tower going up a little further south around the Crowell to Knox City area. So that's what we're watching for the Texas area, and we probably will see continued development from north of Abilene to the Wichita Falls area, and that could be a concern going into the evening hours for Dallas-Fort Worth. It's probably not going to get to Dallas-Fort Worth until maybe around, I'm just hazarding a guess here, probably 9 to 11 p.m. And it looks like more cells going up south of Abilene, southwest of there near Cross Plains, or I'm sorry, southeast, near Cross Plains to Eastland and Ranger out in that area. So this is probably going to form up into kind of a cluster this evening as it moves towards the DFW area. I don't know if we're going to see an MCS out of that. I probably want to peek at satellite or at model data for something like that. since that's still a ways in the future. And then further north, I was talking about that outflow from that storm about a couple hours ago around the Tulsa area, and you can see that. Now, we do have to kind of watch for these storms to pick up that boundary. That could certainly happen. They could move southwest. Also, the baroclinicity along that boundary could increase the risk of tornadoes along one of those cells. So when we're looking at the radar, we kind of want to remember that there's an outflow area stretching from, I guess that it would be, I'm trying to remember the city names there. Anyway, from Tulsa to, I want to say Ponca City, northeast of there, to around Wellington. Then further south, nothing going on in the Oklahoma City area yet, but we can see the Turkey Towers around Sealing, Watauga down to Weatherford. Okay, we're going to go back to the radar. Let's see, do we have any surface data? We don't. So let's check out what we're seeing on the radar. This is going to be in the Wichita area. This is getting about 60 miles from the radar, so we can't really assess the tornado risk on the Wichita cell too much because of range factors. But we certainly can with the stuff near Wellington. And I remember we were getting some tricky data with the Enid radar, so I'm going to switch over to Wichita and we'll see what it's showing. See if we can find any couplets on these Kansas storms. So we're downloading the data. Storm motion we have dialed in is 220 at 10. We'll change that if necessary. And while we're waiting, we'll check these warnings. This purple here is a tornado warning for the Wellington area. 3:54, that's going to be about 5 minutes ago. Source, radar indicated rotation. So apparently nothing really is being seen on the ground at this time. Now if I wanted to, I could go to the Chaser TV feeds, but first we would have to find a feed that's in the right area. Second is that would eat up our bandwidth here. Maybe if we make a big operation out of this and get some money flowing in and that kind of stuff, better internet, and maybe get one of my friends to come help, then we could probably do more of a forecast center, like a ESPN Sports Center play of the forecast picture. But for now, we're just kind of doing the cheap way here. So anyway, radar indication on these storms. Now you can see a problem we have is that this storm, the updraft area is over the cone of silence. By the cone of silence, see the radar is right here. The highest that antenna can tilt up is about 19 degrees. Can't go up any higher. In fact, let me put in that 19.3 here. This is as high as the radar can tilt. So as we're cutting into the far points of the storm, we're up at about 15,000 feet. Looking closer at the storm near the updraft area, we're only cutting in at about 4,000 feet. So the storm is passing over the radar. We can't detect mid-level features, or really even tornado signatures can be difficult. So in this situation, we would have to rely on other radars. Now as far as the closest radar, that's probably going to be the Vance radar. But this is certainly close enough for the next cell down the line, the Mayfield-Wellington storm. So what do we have for storm relative velocity? Do we have any couplets? Well, not really. At 0.8 we can kind of see maybe, let me switch over to my preview and make sure you can see this. Okay, yeah. We're seeing about 24 knots outbound, about 16 inbound. That's pretty weak. Probably got another couplet here, maybe. This is 27 outbound. Doesn't correspond to much inbound, maybe 31 inbound. So a bit of weak rotation in here. So I'm probably not really seeing what they're seeing in the Wichita office. They're probably looking at other factors, or maybe one of the spotters is seeing rapid rotation and they're calling that in. But as far as radar products, I'm probably not really quite seeing what they're picking up. Now, there is this strong inflow notch, so that's going to definitely bias it towards severe weather. Let's see if there's any tilt. Okay, let me set a marker in the center of the updraft area. See that mark right there? Let's see what's aloft, if there's overhang. Well, at higher tilts, it kind of shifts a little bit south. That may be due to an older product time. Yeah, that's 4 minutes earlier. Yeah, it looks like we see a little bit of overhang right there. 7.9, we're up at about 20,000 feet. The overhang, the core of it is just a little bit to the northwest. So right there. 9.9. Let me set the marker in that center of the core right there. 2102. I don't have a new product for the upper level. Yeah, the upper level tilts are newer than what we have at the surface. But overall, I'm not seeing a whole lot of overhang and tilt. Definitely not a beware or anything like that on the storm. It's more like a weak echo region, just kind of like a open vault area. So this is at 6,000 feet. This is the lower level parts of the storm. As we get higher up, I don't see that close off very much. It kind of just fills in. And so anyway, there we go. Not a whole lot of tilt on that. This stuff looks a lot more disorganized to the southwest. This is going to be near, it's going to be northwest of Caldwell, and just looks like a bunch of maybe outflowish junk. Remember I said on the radar we want to kind of keep tabs on where the outflow is from that Tulsa stuff. Let me do that real quick. We're going to look at that outflow running something like that. Not picking it up on the reflectivity. Is that going to be a factor for these cells here? I don't think so at this time. I don't see any evidence of this tracking down the boundary. Of course, that could start. We're going to have to keep it. We're going to have to consider that possibility for the storm near Wellington. Is that going to pick up the boundary? That could be a possibility. If not, it's just going to probably continue moving east-northeast to northeast, maybe something like that. There's also the possibility this cell, if it keeps organizing, that could pick up the boundary. But no evidence of that right now at this time. Stuff near Enid still looks disorganized. This is going to be how far from the radar? Quite a ways. Yeah, 66 miles. I'm going to switch over to the Vance radar. I just switched off my YouTube preview. It tried to force another preview on my other screen. It's for checking video quality, but that eats up my bandwidth. So hopefully this looks a little bit better right now. Alright, so there's our little storm there near the... I don't think that's near any town, maybe just west of Pond Creek right there. So this is almost in the cone of silence for the Enid radar, but not quite. We should still be able to pick this up pretty well with the products we have. See, this is the 5.1 degree scan. This is up at 4,000 feet. 12.5 degree product is up at 11,000 feet. This is getting into the mid-levels. So it's not ideal, but at least we can see what's happening in the mid-levels. This is up at 20,000 feet. And it does look like this has some overhang. Let me set that core. This is 2059Z. Yeah, so the core is going to be just ahead of the storm right here. Okay, here we pick up an old product. So anyway, we've got a little bit of tilt on this storm too. See, there's the inflow notch right there. The storm looks a little bit outflowish though. Let me go back down to 0.4. And let's check out the storm relative velocity. Not seeing much in the way of a couplet here. So I would say weak rotation on this storm. I don't think the chasers out there are seeing very much, to be honest. Looks like this stuff down in western Oklahoma is starting to line out a little bit. Probably what's happening is some storm seeding. Like, remember that tower that we had? Let's see, I'm trying to remember where that was. I think it was out in this area. It's probably depositing outflow downstream and seeding more storms that develop, and the whole thing forms kind of a line. This is what happens when you have the upper level flow parallel to the boundaries, parallel to the dry line that runs like that. You tend to get seeding, and that favors storm lines, like what we have here. So further down the line, here's probably some evidence of the dry line, and then we start picking up the stuff near Vernon. So not a whole lot going on right now. So I think for tornadic risk, I think we've kind of lucked out because these storms aren't really coming together very much. But it's only 4 p.m., so things, could certainly change. I haven't looked at the soundings or the photographs, to tell you the truth, and I should really be doing that. So while that Frederick data is loading, maybe I can pull up one of the soundings. So Norman, Oklahoma, we've got a special sounding for 18Z. So there we go. This is going to be for 1 p.m. So what does this tell us? Well, the surface parcel is going to be running along this line. And as far as the moisture, it looks like we have a lot of dry air right off the surface. See right there at the surface we start out at about 20 Celsius. See, there's the temperature lines. They run like that. So this is going to be a dew point of about 68, but above that, right off the surface, it falls off into the 50s. 2,500 feet is going to be around right there where I put that dot. That's going to be a temperature of about 59. A dew point of about 59. And then we get up to 850. This is 5,000 feet, and we have a dew point of about 54. So we don't really like to see that when we're, looking for severe weather, if we're wanting to chase that kind of thing. Dry air off the surface. So our mixed parcel is going to run something like that. So if we draw our LCL and raise our parcel, it's going to run like that. Definitely some very unstable air, very steep lapse rates, but the dry air is working against us for today. Very strong cap. See that positive area here? Having trouble drawing with this thing, but anyway, yeah, very strong cap. It's probably being removed to a certain extent by the upper level lift with that cirrus you saw moving over. Okay, and then the winds. This looks kind of like a unidirectional photograph because we start out at about 850 with winds out of the southwest at about 25, southwest at 40, southwest at 50. If you draw that on a photograph, you get kind of a straight line. And that's indeed what it's showing up here at the top. So to get curvature that you really need with rotating storms, we've really got to see either some backing of the low-level flow or weakening to make the winds calm, maybe even a northerly wind. It's kind of hard to explain this without making a mess on the screen here, but the surface movement we're seeing is probably going to be like that. See, I drew a dot. This represents northeast movement at about 15 to 20 knots. So to really maximize storm relative helicity, I've got to draw the low-level wind profile to add in a whole lot of area that can be swept out from the surface plot to the storm motion vector right there to the 1 kilometer plot, which is going to be, see, I'm showing here south at about 25. See, that would sweep out a whole large area. And to do that, we would have to get some low-level winds around 2, 3, 4,000 feet out of the southeast at about 20 to 25 knots. And I don't think we're seeing that right now. We could look at the VAD wind profile if we wanted to, but I don't think that's really happening. I may check, because I may end up eating my words later, but if we're looking at unidirectional wind profile, we're not going to see some very strong low-level storm relative helicity. So let's see if I want to check the VAD velocity wind profile. I would go to the Fort Worth radar here. On the College of DuPage side, I would go to product menu and pull up the VAD wind profile. And that's going to look like that. Well, we do have some slightly backed winds aloft, but even down there it's kind of unidirectional. I would really need to kind of plot this out on a hodograph to be sure, but there is a little bit of turning of the winds here. This could probably give us a tiny bit of storm relative helicity. I would have to draw out these plots, but I think that might give us a little bit of curvature. South-southeast at 20, southwest at 35. The critical layer here, this is 5,000 feet right here. It's going to be between this and the surface. So this is where we really want to see the curvature. And to me, just looking at this, I think it is a little bit marginal. We would really have to see the surface flow start veering a little bit to the southeast like that, maybe to the east. And I don't think we have that right now. Surface winds are kind of lacking so far. If that mesolow really pulls together, that could change things around the Red River Valley. Let's update this with current data. We'll pull in the 4 p.m. data. And we'll update the map here. So we're getting a little bit of backing here, but not really a good sustained southeast flow. Maybe in the Frederick area we're getting a little bit of that. So we'll keep an eye on this. See right here. If we're seeing those south-southwest winds at 35 knots up at about 3 to 4 or 5,000 feet, that could give us a little bit of a curved hodograph there. So this would be the preferred area for tornado development in the Oklahoma to Texas region. So a lot of that depends on if the storm can come together or not. It still looks a little bit weak and disorganized at this time. But if you're chasing to get today, this is going to be your storm of the day, for at least for now. So the storm is probably not going to be doing very much right now, but we would watch for the possibility of maybe it picking up some better moisture. And the place we would want to be for that is going to be in the Frederick area, probably. Frederick up to maybe Walters. I don't know if Walters is in that area. I'm sorry, no, Walters is way out east. I'm being stupid here. More towards the Frederick to Snyder area, yeah. So this is probably, if I was going to be chasing, I'd want to be across the river right now in Oklahoma, get out of that bad terrain, wait for the storm to organize a little bit in case it does. So this is probably where I'd want to be, and watch for things to possibly come together a little bit later. And not very much going on elsewhere in Texas. But certainly with this strong forcing coming out with this cold front, that's probably going to be enough to kick off activity in Texas anyway after dark. So things will probably, the picture will probably change a little bit after this evening, after dark, towards 9, 10, 11, and we may see this affecting Texas, DFW area up to Oklahoma City later. May see a squall line develop then. So we'll keep an eye on that. Still pretty early as far as Texas goes. So not a whole lot of change over the past hour or so. I think I'm going to switch this back to the advanced radar. And I'll probably take another break here. Make sure the stream is working okay. So stuff in Kansas right now, it's still looking pretty weak. I'm sure there's chasers out today, but I think so far they're probably very disappointed with what they're seeing. Not much help down there in the Enid area. It's pretty much kind of a disorganized mess right now. So probably the storm of the day is still trying to come together near Vernon. If the stuff near Kansas and the Oklahoma border kind of keeps doing what it's doing, I'm probably going to stop tracking that and focus more on the southern Oklahoma stuff for the rest of the evening. So this looks pretty good there on the Enid radar. This is about 150 miles away. Yep, 150 miles. Looks pretty good up there at those far ranges where there's more beam broadening and it's higher up. Getting 61 dBZs there, that's pretty good. At higher tilts we pick up an older scan. And according to that radar, it tops out at about 55,000 feet. So this still has some potential. This may be the storm of the day. So I'm going to set it on the Frederick radar, and we'll probably take a break there, maybe a 10-minute break, and I'll get some water and catch up on anything I need to catch up with. Looks more disorganized there on the Frederick radar. Appearances can be deceiving, but it's still pretty early and it could still organize and come together. 5,000 feet looks pretty good. It's got some very high DBZs there. It's just not very well organized yet. And at the higher tilts, the core is over the Burke-Burnett area. No, I'm sorry, not Burke-Burnett. I was thinking that was Wichita Falls there. It's going to be north of Vernon, so right there on Highway 283. So yeah, it's got overhang. So it's still got some potential, and we'll keep watching that as it heads toward the Frederick area. So let me take that break that I've been talking about. I'm going to put up an overlay here so people joining know what's going on. Anybody that's watching the archives, people really dig these archives. They get like 50 to 100 views so far. That way they can pan through and just skip this dead air here. Okay, we'll call it 5 minutes and we'll be back. All right, hey guys, we're back here. 4:30 here on Tuesday, is it? Yeah, Tuesday, April 26th here, watching our storm of the day coming together near the Frederick area, crossing the Red River. And we were looking earlier at the stuff near Kansas, and it wasn't looking all that great. Had a couple radar indicated tornado warnings on that. I'm not sure if anybody saw anything, and looks like maybe this stuff near Watonga is also coming together. It's still pretty early on that too. It's probably going through the process of organizing. But the stuff near Frederick isn't looking too bad. There, as we saw in the soundings, there are dry air problems, shallow moisture with dry air just above the surface. This is typical of early spring. Almost May, but not quite. So anyway, here's our storm of the day. It is getting close to the radar there at Frederick, so the cone of silence may be a problem out in that area as it gets closer. But for now, let's go up to the higher tilts. 0.9, 1.3. Okay, see how it jumps back here? We've got an older product here. But there is a little bit of this bow shape. You see that? That's indicative of the storm probably generating a bit of outflow there. I don't see really a core here sitting right over the updraft. Looks like it's trying, but it's not quite organizing very well. See, this is up at 25,000 feet. The core of that is right in this area. Let me set a marker. Of course, this is an old scan. This is for, well, 2129. Yeah, that's probably okay. So it looks pretty similar to what we have on the low-level radar picture. So I guess I don't really see very much tilt, though it is producing prolific reflectivity at the surface. It's trying to organize, but we're not quite there yet. We're probably seeing just a whole lot of dark sky, probably a little bit of an arc cloud out ahead of it. And as far as where the updraft is, It's probably going to be out in this area, maybe just ahead of it like that. So it probably looks a little bit like the RFD area of a supercell, what you would see along that. And what's out to the south, I don't think this is much of anything. Although, well, there are some higher reflectivities out here, so that might be the area next in line for development. So yeah, I'll say we should probably keep an eye on this area too. But further back to the southwest, I don't think that's really doing anything at all. We'll keep an eye on these higher reflectivities and see if that develops later. But for now, I guess our focus is probably going to be on this area here. Storm relative velocity is not really showing very much. Maybe a little bit of convergence out in this area as we get outflow surging that way. If we go to base velocity, we can kind of get an idea what the outflow speed is. It's showing about 25 knots out here. So storm is gusting to the west out in this area. So you see that right there. Storm gusting out and kind of feeding the outflow of this next storm down the line. But as far as the updraft area, we're not seeing anything in the way of a couplet or anything like that. Sometimes when it's not showing up very well, I'll kind of play with the storm vectors and change that a little bit and see if I can tease any detail out of that. And I don't think we're going to really be able to do that. Just not showing any organized rotation on the storm. Oops, that was an accident. We're not going to use these products until we get a little bit of organization of the storms. So I'll switch back to the panning mode. And there we go. This is probably a good time to check out the satellite. So we will switch over to Mikitis. So there we go. That storm near Sealing in Watonga looks pretty spectacular. See, we have a 415 image, and you can see some good shadowing out ahead of that cloud. See that right there? Let me zoom in on that. And we got a new scan while we were checking that out. So there we go. There's our Kansas stuff up to the north, and then there's stuff near Sealing and Watonga is right there. And then further down the line, you can see our Frederick storm right there. And what do we have further to the south? Don't really see anything. We've got the cold front storms just to the west. This is along the Caprock right there. Strong cold front moving through West Texas. That'll be in the North Texas and Oklahoma area later this evening. Then further to the south along the dry line, I think we're looking maybe at something like that. Not much going on at this time down there. Then we'll check the warm sector, the moist sector out ahead of it, look for any boundaries, and I don't really see anything in this area. See a little bit what might be deeper moisture out in this area. And I can see some transverse banding in that area too, so we'll keep an eye on this for the possibility of that organizing. Maybe that will tap into this stuff and strengthen a bit. So we're going to watch that Watonga stuff. I think the Kansas activity is probably too far gone, and I think that may be out of the picture. So we'll focus on the Oklahoma activity over the next hour. So we better take a look at that stuff near Enid. We'll pull up that radar. These level 2 data sets are a little bit large. They're a couple megs, so it can take a couple minutes to download them, especially when we're moving video through the internet feed like we're doing. But we should have that here any second. While we're waiting on that, I'll take a look at the visible imagery just one more time. Where we don't have transverse banding, you can get a very good idea of the low-level flow by following the cloud streets like you see like that. You can see a little bit of the backed flow through the Fort Worth area up to Wichita Falls associated with that mesolow south of Childress. As far as do we have backing in the Oklahoma City area, I'm not for sure because it's kind of obscured by transverse banding, because you get shear being more of a factor in the cloud textures, so it's kind of hard to really tell up there. But in any case, this is probably going to be some deeper moisture. We're going to have to keep an eye on the storm as it gets into the Enid. I'm trying to remember the town names, Dover, out in that area. That would probably, if I was chasing north of I-40, I would probably want to set up in that area south of Enid and just watch for that storm as it comes westward. And I forgot, we do have the Oklahoma mesonet. Let me show you that real quick. So if you put Oklahoma mesonet into a search engine, you can pull up the plots and really get an idea of what the moisture, wind field, and all that is looking like. So I'm going to help you figure out which plot to pick. Probably the simplest way of doing that is just use the page that I have already set up rather than go through their website. If you go to weathergraphics.com/WX, you're welcome to use this. And there's going to be see that mesonet right here under analysis? There's going to be a plot that'll come up. So how does this help us? Well, we can look at the dew point plots, because at this time a lot of the shallower moisture will have mixed out, and we'll see depressed dew points where that mixing is taking place. But so far it looks like the moisture is kind of hanging on across most of Oklahoma, and if we draw this 68-degree isodrosotherm, we're going to see something like this. So I'm plotting 68. This shows the enhanced moisture field that I was showing there on the satellite image north of Oklahoma City. And that corresponds pretty well to what I was showing you earlier as far as where to set up for a target location out in this area. So that's where I would want to be, just west of Interstate 35 around the Henrietta to Dover area. I'd have to check that on a road map. My knowledge of the roads out there is a little bit rusty, but I think that would be right, just south of Enid, maybe a little east of there. Do we have 68 elsewhere in Oklahoma? Well, we've got one just north of Tishomingo, Durant. No, that's not Durant. That's going to be around Ardmore to Tishomingo. So a little bit of a pool of higher dew points in that area. Does that help feed the Frederick storm? Not really. However, the winds are a little bit more back there around Frederick. So here winds are out of 150 and even 140 to 130 around. Yeah, I guess that would be Frederick out in this area. So we may see a little bit better photographs set up for that cell coming across the Red River right now in this area. So still some potential out there. As far as elsewhere, the dry line is running like this. And back behind that we have the post-dry, if you want to call it the post-dry line air. Dew points running 40 to 50, and then behind that, look at that. That's the cold front coming in, and we've got southwest winds behind that, even southwesterly. Probably outflow influencing that to a certain extent. But a definite change across there. You get temperatures dropping 20 degrees, very gusty winds, and slightly higher dew points with that Pacific air coming through, probably being helped a little bit by outflow. So this is probably what we're seeing further down the line around the Amarillo area. And that's what we will be seeing in the northwest Texas area later this evening, and in central Oklahoma also later this evening. So probably some potential for an MCS event later on. Okay, back to the radar. What do we have here? We're on the Enid radar, Vance Air Force Base. Not looking too impressive, really. Pretty typical multi-cell, line multi-cell right there. Go up to higher tilts. What do we got going on? Well, we've got a higher core right there, higher intensity core up at about 18,000 feet. You can see I set a mark there. That corresponds well with the upper level data. This is up at 37. And we top out there at about 42,000 feet. And that's stacked pretty well over the tail end, what we call tail end Charlie of this line. And this looks to me like just a multi-cell. Probably looks pretty good if you're down on the ground, but you're not going to be seeing any tornado action out of something like this. We would probably have to wait a little bit later for that to happen. So not all that impressive so far, but like I said, we'll have to watch the storm as it gets into this area right here. We'll see if that better moisture helps pick it up a little bit later. And further down the line, this storm north of Vernon, west of Frederick, is still hanging on there. And to really pick that out, we're going to have to switch back to the Frederick radar. So let me do that real quick. So we're getting severe warnings all the way back to the cold front. Pretty strong cold front coming through there. A lot of gusty southwest wind back behind it. So we got a severe thunderstorm warning there for Gray County. 60-mile-an-hour winds. It looks like a little cluster coming together near in the Sweetwater area, Sweetwater to Snyder. So that may organize later in the day. This is along that cold front. And it looks like we're trying to pick up a few cells along the dry line around Eastland and Breckenridge. Nothing organized down there, but, you know, we'll watch that. Tops on that are probably not very high. Stuff around Breckenridge is topping out at 32,000, and the stuff along Interstate 20, that's topping out also about 30,000 feet. So focusing on the Frederick area, now we're seeing a little bit of organization here. See that kind of resembling a hook. Probably tapping some of that better shear that we saw there on the Oklahoma mesonet, indicated by the surface data. So do we have overhang on this yet? We have to go up to higher tilts. Well, let me go back here. Okay, latest image we have is 2145 at the surface. So we're going up to higher tilts there. Don't have really a single distinct core there. This looks more like a line on the higher tilts. Looks like more what we would see on a squall line, on a short squall line. See, this is up at 20,000 feet there, and it shows up as a line with a higher reflectivity in this area here along, what is that, 283? Yeah, north of Vernon. Actually, let me grab that last frame that came in. Okay. So there's the core of that south end of that line. What does that look like on the lower tilts? Well, here's the core. We've got some very strong reflectivity aloft. So down at the ground, there's probably a very dark sky, probably a lot of lightning, cloud of ground lightning, and probably some precip about to hit the surface in this area. So we're seeing kind of a line forming along this with no definite area for like a meso or tornado to watch. So if I was watching this come together, I would probably get some distance and maybe set up a little bit further to the east and just kind of watch it. That curvature there, that's kind of interesting, but yeah, okay, yeah, see, we're getting a little bit of a couplet coming together here. However, this looks more like, let's see here. See, we have some very strong outbound right there. I'm sorry, we're up at 4.0. We need to fix that. Okay, so we do have circulations aloft, but let's see at the surface. I see some strong outbound here. Well, I'm not going to say that's strong. Some decent outbound 25 knots right in this area right here. That's probably inflow into the storm. Let me switch over to the reflectivity so you can check that out. There it is. That's feeding into that area, kind of like a weak vault in here maybe. And maybe some evidence of some weak rotation. See, I'm seeing about 15 knots inbound, 25. That's not very strong, but it's kind of like a weak meso, like right in this area. Then aloft, we pick up that other rotation I was talking about earlier. See there, we have 18 knots outbound and 41 inbound. So that's about 50 knots a shear right there. That's across a distance of about about 3 miles right there. So that's going to be a meso right in this area. So we'll watch that and see what that does. Of course, one problem we have is there's a lot of this rain in the inflow area. So really not the ideal setup. And we're seeing that tail end start to fill in a little bit. And then further to the southwest, what's going on down there? Nothing too organized right now. Let's see, tops on that stuff. This thing here is topping out at about 43,000 feet. Sail down to the south is topping out at about 35. So this is probably a new cell trying to come together. That's going to be west of Vernon. And this is all along that dry line. All right. So right now I'm just looking at different tilts, seeing if I can find any interesting features here. And I really can't too much. Got that mezzo there. And I think it's not showing up so well on the newer products. I think that rotation is kind of falling apart. Looks like this whole thing is just kind of outflowish. See, I'm seeing 31 outbound, maybe 10 inbound right in this area, 10 to 20. So this is our new mezzo right here. I'm going to mark that. That's embedded in this junk right here. So this isn't really the optimal chase day so far. Okay, I'll zoom out real quick, make sure we're not missing anything. It's like one little isolated cell there near Graham. Tops at about 33,000 feet. And when I do zoom out like that, I need to flip down to the lower levels tilt. There we go. There we go. That's a better picture. Stuff out ahead of it, not really organizing. Activity along the cold front. That's not very well organized. So just kind of a mess today. Alright, so this is probably a good time for me to take a break. I don't want to keep going through this nonstop because I'm going to kill my voice doing that. I will set this on the current activity and bring up that window. I'll try to play some music. It's not the best music because the last program I did on August 11th, I got a notice from YouTube that they found one of those stupid songs. I guess it was a cover of Phil Collins, and of course they flagged that and said that they had to put ads on that they were watching it. So usual BS with copyright with music, so I'm going to put on some royalty-free music, and that's probably about the best I can do until I can find some other sources. So I'm going to put this as back at maybe 5:05. So we'll call it a 10-minute break, and I will get refreshed, and we'll probably have some new developments, maybe. We'll check it out. Hi, Tim Vasquez here. We're checking out this situation here today on April 26th, and we've managed to squeak a little radar indicated tornado warning on the cell northwest of Frederick. Let's get some details on that. You're probably seeing a little bit of shear there in that storm. Source radar indicated rotation right there. Don't have any spotter confirmation of that, but looks like they put that in to kind of cover things in case things really pull together here. And you can see a little bit of curvature here. We were watching that about 10 or 15 minutes ago when we had that bit of circulation come across the Red River. We're pretty close to the radar, and we need to look at the higher tilts. So let's do that real quick. It's like a pretty good chunk of a core to the south of that circulation. And as we go up to higher tilts, this is 15.6, and now at 19.5, this is up at about 25,000 feet. We're looking at the core of that storm kind of in this area. So I'm going to plot the center of that right there. And that's a little bit of overhang, but this is very rain-filled out ahead of that storm. Let's look at the storm relative velocity. Well, what do we have here? Remember, we have to remember where the radar is, and that's going to be in this direction. That's the Frederick radar down there. So here we see a little bit of inbound and maybe some weak outbound, and it's kind of tight. This is maybe across, let's see, about 1 mile. But the intensities are not very strong. There's 23 knots inbound and maybe 10 outbound. So this is not what we see with a very well-defined tornado. If we go up to higher tilts, well, we've got a slightly older image, but we'll check it out anyway. Here we have 20 knots inbound and about 24 outbound, so about 50 knots of shear there across 1 mile, so probably some decent rotation. I wouldn't call that quite tornadic on that frame. And then we go up to higher tilts and we see more of a meso. We kind of consider the big picture. We have a large area of outbound, large area of inbound. And this is across, let's see, plot a marker. That's about 3 or 4 miles. And that's going to be about 40 to 50 knots of shear. So just kind of a meso centered right in this area, drifting northeast, and probably an embedded circulation that triggered that tornado warning a few minutes ago. And I should point out that that was at about 4,000 feet. You can pick out the meso a little bit better here. See that? There's strong inbound and strong outbound. This is about 36 knots outbound, 29 inbound, so that's going to be about 60 knots of shear across maybe 1.5 miles. So that's a tight meso with a little bit of, I would call that moderate circulation right there. This is up at about 7,000 feet. Then higher in the storm, meso's a little bit stronger there. We have 44 inbound, 35 outbound, so about 70 knots right there. So circulation is definitely there just northwest of Tipton, but not reflecting too well in the lower scans. This is 0.5, 0.9, 1.3. Don't see that quite as well. So this is mostly mid-level rotation. So see, not a whole lot going on at the surface, but if we go up to higher tilts, we'll probably see some evidence of that rotation. And to tell you the truth, I don't really see it there on the reflectivity. There's 5.1. I would expect to see kind of a vault in this area, but it's not very well defined. I think there's a whole lot of seeding along this line, a lot of precip being dumped upstream, kind of, or downstream, kind of like that. Anyway, we don't want to get too focused on this area because there could be other stuff going on down the line. So we got to watch what this is, what's going on down here. Look at that, we're forming an MCS. So this will probably be the story of the evening, or the big picture. I wouldn't call that a news story, but that's probably just the overall pattern we're going to be seeing over the next few hours. So chasers, when they are encountered, when they're seeing this, they like to go to the south end to tail end Charlie down there. And what's going on with tail end Charlie? Well, there's a little bit of discreteness to the storms. There's one cell there near Chillicothe and another south of Flower Mound. Of course, the stuff up here. Okay, look at that. See that at 1.3? It's got a very discrete appearance. So, and there's this curvature. So this could be the early stage of a supercell coming together. If it's not seeded too badly by the stuff to the south, that's going to get entrained into this storm up here. So we'll kind of have to see what goes on. If that stops happening, this could very well turn into the storm of the day. So I really don't know too much about the stuff up near Frederick. I don't think I'd want to place bets on that just yet. This would have me very interested down to the south. But of course we want to watch for consistency over time in case that's just a fluke right there. I don't see a whole lot of very strong reflectivity being suspended aloft over that storm, so it doesn't look like the updraft is too strong on that. Let's see, the strongest core is just south of Chillicothe, so I'm going to put a marker right there. So that's a strong core. That's going to be up at about 45,000. I'm going to drop down to lower levels. Core is pretty much in that same area. Then I drop down to even lower levels. Let me go back and see what time that was. Okay, that was 2207. Okay, so that's good. Now I would like to see that core more in this area to support this storm here, but that's not the case. It's kind of concentrated down here. It looks like it might be associated with this tail end stuff. So we'll have to kind of watch and see how that pans out over the next couple frames. Okay, back to southwest Oklahoma. I think we're starting to see a little bit of that rotation going on here associated with that meso. This scan here is up at 6,000 feet. Let's see what the storm relative velocity looks like. Okay, showing a pretty good bit of rotation here. This is a couplet. See that very strong outbound and marginal inbound. The inbound velocities are only about 20 knots, maybe 27. The outbound, however, is 44 knots. This is about 70 knots of shear right here. The diameter of that shear is about 3 miles. So this is a meso, just north of Tipton. Right, we'll go up to 4 degrees. Meso is still there. 6.4, it kind of weakens. And don't see much from that. Drop down from 4.0 to 3.1. And I'm not seeing any circulations in the low levels. So it looks like mostly mid-level stuff going on right now. some pretty good inflow. Looks like right there. This is northeast of Tipton by about 5 miles. So that's probably feeding into that storm. So that would be inflow running like that into that storm like that. So it looks like that inflow area is kind of cleared out a little bit. So that could support the strong circulation continuing for a while as it moves to the east-northeast. So if I was a chaser out in that area, I'd probably drop down south of Snyder along this, what road is that? 83? 183? Yeah. So I'd probably want to be in this area just in case something happens. Some chasers may go further down this road, because if you're down here and you got to move northward as that storm approaches, you're going to have to go through the Snyder area and deal with congestion here and then move eastward. So some chasers will move eastward a little bit depending on what they think the storm is going to look like as it gets in this area where it's visible very well. Okay, then further down the line, let's see. Do we have a circulation on that stuff near Vernon? Nothing in the low levels? Okay. I'm going to see if I have a different color palette. The way we do that on GR Level 2 is we go to the GIS menu at the top. We go to Settings. I'm sorry, I think that might be done under the File menu. Okay, it's View now. Okay, so View, Color Table Settings. And this is where you can set the color table you want to use. So storm relative velocity is right here. I don't really like the defaults too much, so what I usually do is go to my own pre-selected tables. I've got a couple palettes saved here. Looks like I didn't like that palette. It's probably not compatible. Anyway, there's a couple of sources you can go to get new palettes. These are not too difficult to analyze, to edit by hand, because it's just a plain text file. It's nothing really too difficult. Yeah, let's see. You can do a search for GR Level X palette. There's a couple sources for these. This Red Team WX has a few palettes on their website. So there we have GR Level X color curves. And it looks like these color tables are differentiated by version number, so there's probably some differences across them. We're running GR Level 2, version 2X. I'm going to give this one a try. Actually, there you see the format of these color palettes. It's plain text, and you can kind of edit them as you go. The figure on the left is the value for, like, in this case it would be velocity, and then you have like an RGB specification. There's another number in there too. I'm not sure what that is. Anyway, I'm not going to worry about that too much. Let me just save this real quick. So save that. Okay, it is saved. I'm going to try to download that. GR level X. It appears that these files have to be a PAL file, so I'm going to change that real quick. I'm going to change the extension. See if that picks it up. Okay. Looks like that's going to take some tweaking. I'm not going to worry about that right now. This default palette that GR Level 2 uses is not really my favorite, so I like to change these when I can. So let's see what's going on with the weather now. These storms are very close to the Frederick radar, so I'm going to go up to a slightly higher tilt. See, that brings us up to 2,000 feet with these storms here, and I might even go to 1.8. That gets rid of a little bit of the ground clutter. So you can see a little bit of that curvature right there that we were looking at earlier, not a whole lot of change. Storm relative velocity, do we have any interesting patterns? I can see a little bit of that meso there. See that rotation? We have inbounds right there. Some strong outbounds like that. And this is probably painting out the outflow. Looks like that. Let me try drawing that like this. Here we go. So I think we're picking up the outflow from the storm looking like that. And one product that is often neglected is actually the spectrum width. So see that? Now you can see the outflow. Looks like that. That can help tell you if your storm is getting outflow dominant. Let's compare that with the base reflectivity. So memorize the location of this. Switch over. So yeah, we're getting the outflow starting to push a little bit ahead of this storm right here. But it does wrap into this area of interest right here, northeast of Tipton. So we're going to keep an eye on this area right here. And if we were chasing, we would probably want to be maybe in this area if we wanted to get good shots. Of course, you always want to have an escape plan to make sure you can go south if anything does form. But overall, this isn't really too bad of a situation. You're going to be able to see this coming at you from the west, and this road here is pretty clear, so you'd be able to move with no problem. So what do we have aloft? Do we have any overhang? Not really. The higher cores, the higher reflectivity cores, are still focused on this area. Well, maybe a little bit of tilt. You can see right there. Let me mark that. This is up at about 15,000 feet. Let me mark that. Compare that with the low-level scans. Yeah, we do have overhang above the inflow air. So yeah, this is definitely looking like a severe cell that's part of this larger line. So we'll watch that. So going back down the line, anything going on? Well, the tail end is filled in a little bit. It is not really broken off into a discrete cell yet. It's still churning and not doing very much. And you can see as we go to the higher tilts, not that one. Yep, that's the ultimate tilt, 22,000 miles. Anyway, go back to the surface. The upper level scan. This is up at about 38,000 feet. You can see that this shows that the dominant cell is over 287, Highway 287, northwest of Vernon. So this is favoring the tail end cell. Down here is being favored, and nothing up here. This is probably just junk being deposited by the cell to the south. So if I was stuck down south of the Red River chasing, I'd probably want to be maybe on some of these roads in this area and just watch what happens in this region right here. So what do we have as far as rotation? This is about, let's see, how far is that from the radar? Let me set a marker. This is about 22 miles. That's not very far at all. So it's showing some outbound right here. See that stronger outbound core? This is probably inflow into that storm near Chillicothe. Let's compare that with the reflectivity. Yep, so that's inflow into this storm. And actually the vectors are probably going to be more like this. But the radar is detecting the component of motion along this axis, this way or that way. So there's a component of motion that's going this way. It's being detected by the radar, but the actual winds are probably running more like that, or maybe easterly like this. So this is the dominant cell right there, right on 287. Okay, going up to higher tilts, do we have a meso in the mid-levels? This is up at 5,000 feet. Well, not really. Of course, this may not be the ideal viewing location because we're sampling it from the northeast like that, so we may not be detecting the meso very well from that direction. See, we've got a lot of outbound like that. I think that's range folded actually, or not range folded, that's aliased. Minus 28. Yeah, that's strange. I don't know why the radar is picking up all this strong outbound. Like I said, this is probably actually, it's probably not being de-aliased properly. I'm sorry, I'm screwed up. This is inbound. Okay, yeah. This is just strong upper level flow moving west to east. The negative indicates that this is inbound, so this is probably some stronger winds aloft up at 36,000 feet, probably picking up a little bit of the jet stream energy right there. Spaced out there for a second. That'll happen sometimes. Anyway, the main factor is we're not really showing a mid-level meso there, but there is some strong inflow going into that storm. So there you go. You got some bullet points for what you're seeing with that storm. Mostly it's organizing, getting some inflow. So we're going to keep an eye on that south tail end. If we were chasing, we'd want to be in this area right there to get a good view of it. It's like a flood warning just went up for this stuff. Yeah, flash flood warning for Kiowa, Cotton, Jackson County because of that training. If you're hanging out here, you get one cell pass over you, then these other cells pass over you, then these pass over later. So that's a good flood situation, flash flood situation. Okay, as far as our tail end cell, newest frames have come in and we're not seeing very much circulation. It's like it's weakened a little bit. Okay, let's check out what's going on elsewhere up the line. We've got just disorganized junk up to Hobart and up to I-40. Go up a little bit further north. Look at that. The cold front is pushing on in. Actually, I don't know if that's the cold front. That may be outflow. Let's pull up some 5 p.m. data and see what's going on here. We'll see how quickly that cold front is coming, because if it is moving very quick, that's going to undercut a lot of this activity. Okay, we'll erase and then plot. You can see those backed winds in the Red River Valley, Wichita Falls, Vernon, Frederick. We're showing winds out of 140 to 150 at 15, and that's giving us a little bit of curvature there with the hodograph. And we're bringing in some decent moisture, 66, 67 dew points. Again, it's not going to be very thick, but anyway, we'll watch that. And as far as the cold front, it looks like it is advancing into the western counties of Oklahoma. We should go over to the Oklahoma Mesonet and take a look. Okay, we'll refresh. 525, look at that. 55 knots, gust to 55 knots. Is that knots? No, it's miles per hour. But that is some hella strong winds coming out of the western counties of Oklahoma. Look at that, 46 there at Slap Out, 42 there at Fairmont, or no, it's not Fairmont. I don't remember the name of that town. It's up in the Panhandle. So cold front looking like this. And that is a very strong cold front. There we go. So this may very well undercut, in fact it is undercutting the dry line. Let me draw the dry line in red. So there we go, we are undercutting the dry line. So this is going to favor, once that catches up to the stuff near Frederick, that's going to rapidly line out a lot of the activity. Because this is like a wall of forcing. It's the ultimate wall of forcing, and you're going to really line out whatever is out in the warm sector. So if you're chasing, that is going to be a factor, and that's the average wind speed is 30 knots, so that's going to probably be in the Oklahoma City area, probably within a few hours. As far as what's going on in Texas, well, Texas does not have a mesonet. It's very sad. Texas Tech there in Lubbock, though, they've been pioneering their own little mesonet, and I don't know if they have any data. Let me check Google and see if maybe there's some mesonet data we can draw upon. Texas Tech Mesonet. There are some alternate sources we can go to, like Weather Underground. They've got sort of a mesonet from hobbyist data. But the problem is the data is a very inconsistent quality, so you can never be sure what you're looking at, and I don't think it's appropriate for a day like this. The stuff at Texas Tech, that's going to be a lot better. There's a lot more quality control with those sites, so we can trust what we're seeing there. I haven't been on this website in quite a while, so this should be kind of interesting. So they've got plots here, and at the bottom we always want to check and make sure of the time we're looking at. And it's showing 2200, so that's going to be 5 p.m., 30 minutes ago. So this is a good product we can use. It's very useful. The problem is I don't see it showing gusts, so we're going to have to look at the flags on the wind plots, kind of see what's going on. Alright, so what do we have here? Looks like the cold front is going to be something like this. And then I'm integrating this with what I know about Oklahoma from what I saw on the Oklahoma Mesonet. That's going to go something like that. So we're going to watch for maybe this boundary when it gets up to Knox City and Crowell and Quanah. That's going to probably start undercutting some of that activity. But for right now, that stuff is mostly dry line activity. And let me draw the dry line in red. Okay, the dry line is going to go like that. Remember, it caught up, being undercut there in southwest Oklahoma. And then it runs something like this. See that 43 there at That's going to be Stanford, Anson, I think. My knowledge is kind of rusty with some of those sites. And then here, along I-20, that's down to the south. Let me move the window. Here we're getting closer to I-20. This is Abilene right here. That's Dyess Air Force Base. This is Sweetwater. So you can see the winds are kind of backed in this area. And that's good to know because the backed winds are going to provide more curved photographs. So there's our dry line. And so what I'm doing really is a surface analysis so I can kind of blend this in with what I'm looking at on the radar. So there's our cold front undercutting the dry line, and then it goes something like this. It doesn't look like it's quite caught up to these stations here around Big Spring. Looks like the punch is mostly into southwestern Oklahoma. In fact, look at that. The winds are out of the northwest. Okay. So the main punch is into southwest Oklahoma, so we should see some very fast progression in this area. Looks like there's a punch through here also. So it probably will punch eastward quickly through the Knox City area and not so much down around Sweetwater where we have, well, looks like the winds are pretty strong down there. So yeah, the whole thing should probably continue advancing eastward during the evening. So this is a very good site. It's going to be mesonet.ttu.edu. So I'm going to have to add that to my page. That's a good site to look at. Plenty of data there. So you want to use that to supplement your analysis. Back to our messy radar. Look at that. It is a mess. But remember, when you do that surface analysis, you can tie that in and start making sense of it. This is the reason I went over and looked at that stuff. So we know that this is the cold front. So you can look at those echoes and you can think to yourself, well, that's the cold front, and I know what that is. In fact, it looks like it may have pushed through Quanah already. So all of this stuff is cold frontal activity. And then the dry line, I'm going to draw that in red. The dry line is something like this. So it looks like we're going to have to watch for that cold front to catch up and underrun this stuff here in the next, the stuff near Vernon in the next maybe hour. I would say it's probably got about an hour before that happens. And then it will catch up to the Fairview activity maybe in 2 hours, we'll say. And then by the time we're rolling around 7 or 8 p.m., we're probably going to see a big MCS. Let me start over. Probably going to see a big MCS, I would say, through this area here. Because if you look at the big picture, we've got a whole lot of moisture set up. Not very thick, but it's there. Big wall of forcing, so going to have a line of storms here. That will kind of shut down the tornado risk a little bit, but we'll have to watch for high winds to become a factor, derecho type stuff. We'll watch for that. So further down the line around Big Spring, Sweetwater, Abilene, I guess most of this is dry line activity. Remember, we analyzed and we found the cold front looking like this. This looks to be dry line storms. I'm going to have to reanalyze that because I don't know that for sure. This is an awful lot of activity for a dry line, so it's possible the cold front may have moved into that area. So the storm of the day is right there near Vernon. Let's check, see this boundary right here? Let's see if that's outflow or if that's the cold front. The way we can tell is to see which way it's moving. If it's moving westward, it's probably outflow. If it's moving eastward, it's probably a cold front. So here we go. We're going to animate it. Kind of a complex shape there. But this is more indicative of outflow. Possibly even the dry line we may be, because this area here has not had a whole lot of convection. So this could be basically where our dry line is set up. If we were looking at outflow, we would see kind of a more aggressive westward appearance like what we saw here. See that right there? Let me run that. And you'll see it pushing westward very quickly. What's interesting about that is that's where we had that very strong storm about 20 or 30 minutes ago. And it was strong enough to kick that outflow westward in that particular spot. So the rest of it, we're going to call this a dry line. Probably some towers and maybe some dust and pollen and whatever else being suspended aloft, getting some reflectivity from that. And then this is going to be the cold front. So in these complicated situations, you're looking at all these products and bringing them together and synthesizing them in your mind, and it really helps you make sense of what you're seeing on the radar when we're in a situation like this. So drilling down to the small scale again, looking at our possibility of severe weather. Remember, if we were chasing, we'd probably want to be set up here. And we've probably got a good view of the storm moving into the Snyder area. But it looks like that circulation there is kind of diminished a little bit. You can see it aloft. See how they're at 1.8, 2.4. We're seeing a little bit of that circulation. Storm relative velocity, it's showing a little bit of that continuing. But there's the outflow right there. Let me make sure we're on the... Yeah, I forgot we were looking at an animation, so let's go back to this again. Okay. Storm is moving into the Snyder area, so if you're chasing now, you've got the outflow pushing through. Spectrum width. Not really showing the outflow quite as well now. Storm relative velocity. Also not showing the outflow. Well, actually, yeah, there it is right there. Looks like the outflow is cleared. 183 right there, pushed eastward. So if we integrate that with our radar, we know at the surface the outflow is pushed through here. And it is wrapped into the stuff near Snyder, so this is the area we're looking at. So remember when I was talking about chaser positioning, I was talking about some more chasers being off to the west, the east possibly. Those people would now be in a good place to watch the storm. Whereas the people down here are having to reposition and go westward or eastward. So there's some pros and cons to positioning yourself around these storms, depending on how much time you want to do what you're going to do and what you think the storm's going to do. Looks like there's still some pretty decent circulations in the storm. We're getting 32 knots of outbound right there, 25 inbound, so a little bit of rotation in this area. Looks like convergent rotation actually, so that could be a weak, like a rotating wall cloud type deal over the Snyder area. We got a little bit of consistency aloft, and we actually see the meso on this. See the outbound right there, and then there's the inbound here. So the big picture is we have a meso like that, and embedded in that we have maybe a rotating wall cloud, or it could even be a small funnel. I don't know. This is when we need spotters on the ground. Check that out. But it is detached from the main area of warm air, which is over here. See, there's the outflow. So anything that's going on here is in the process of dissipating, and then a new meso is probably going to be forming relocating, establishing itself east of Snyder. Then we go aloft. What do we have here aloft? Not a whole lot. Picking up more of the anvil motions at those levels. Okay, so that's the picture of what's happening there at Snyder. So to kind of help you make sense of that, outflow looking like this. This is kind of an RFD-ish type structure. Forward flank type structure right there. A little bit of a rotating wall cloud back behind the outflow. Then the rest of the outflow is like that. So you could either hang back in that vault area and try to see what's going on here, or you could get out of the rain and stuff and try to move eastward down the highway. And in fact, the way the storm is moving, you're probably going to have to start moving north up some of these farm roads to really follow that storm. And as we go up to higher tilts, you can see more of the mid-level rotation like that. So this is the mezzo just east of Snyder. Then if you want to see that rotating wall cloud type stuff, that's where you go down to lower tilts, and you can try to look for that in the reflectivity data, but you're going to see that more with the storm relative velocity right in that spot right there. In spectrum width, well, if you were suspecting a tornado on the ground, this would help you find a debris cloud. The spectrum width is very unused. In fact, a lot of your good radar sources on the internet do not carry spectrum width, and that's really a shame. But you would see higher diversities of spectrum width in a debris cloud. See the scale here, you would be looking at higher diversities, higher variation of velocities within a volume, within a radar bin, and you'd see like maybe 8 to 12, 16 to 20 reds, browns, and yellows in a debris cloud. Maybe just for fun, I can pull up a sample of this real quick. Let me go into my archives here and give you a little bit of a treat. And I'll pull up, let's see here, let's look at the Arlington storm. Was that 2012? You can see I've got a lot of cases here. It might have been 2011. I know it was, yeah, 2012. Texas Fort Worth supercells, there we go. Level 2 data, I think that was more towards 1:30 to 2 p.m. I'm going to try the 1840 product. Pull that up real quick. I need some sort of overlay here to show that this is not live, so hopefully I don't freak anybody out when they dial into this presentation. Let me get rid of the GIS. So this is what you would be seeing if we had like an emergency or a PDS and I was walking you through the products, but let's see, show shape files, there we go. So this is the Arlington storm there near, you can see the hook echo, much different from what we have today. If we went to storm relative velocity and checked that out, well, we don't see it too well because we're at a low tilt and we're very close to the radar. And this is not a very good palette color here, so let me change the product a little bit. I'm going to take that up to, let's see, 1840. Let's try 1854. I want to find that really tight circulation that you see with tornadoes, with your classic tornadoes. So I'm going to have to kind of like play around with this and get a good frame so you can check this out. I'm not seeing one even there. This kind of shows how, you know, even though we know that there was a tornado on the ground at that time, this shows that sometimes a certain product is not really going to stand out and you have to look at other products and really kind of pull things together. This is the reason the algorithms don't always work. It takes a lot of blending of data and a lot of experience in really synthesizing things that you're looking at. I'm going to do one more try here with the 526 now. Let me try this one more time. Do 1845. I guess this will work. Let me try one more. Sorry, I'm kind of messing around here. I'm trying to show you a very good example of the kind of tight velocity that we usually see with these tornadic circulations. I'm probably going to have to settle for this one here. So here we have 21 knots inbound to the radar. Here we have 52 outbound, and I kind of want to settle out that bias by increasing the storm motion vector. I'll bring that up to 25. Bring that down to 15. Kind of balance it out. There we go. So if I set a marker here and then measure this out, I'm looking at about 3 miles diameter on that rotation. And the rotation is about 29 inbound, 33 outbound. That's about 60 knots of rotation. So it's not really jumping out on these particular radar scans. I would have to find like an ideal time in the storm's life cycle to really show that to you. But here it's even tighter. I've got 23 inbound, 33 outbound, so that's 50 knots of rotation right there. And what I was going to show you is the debris cloud. I don't know if that's the debris right there or not, but let's back that up a little bit to 1850 and see if we can find the debris. Because what I'm showing you is how you can use the storm relative velocity, or I'm sorry, the spectrum width, to pinpoint where a tornado is occurring. So let me go back to 1830. Well, I'm not really finding it. This could be, to a certain extent, some of the inflow into the storm. Let me pull up one more example. One prominent example is May 10th. This is a tornado that affected the neighborhood I was in there in Oklahoma. I had neighbors on the property exactly next to me that had fatalities and had to be dug out from under the debris. So this really affected me personally. And I think we're going to see a much different presentation here. So I'm going to back this up to 2242. Okay, and then we'll back it up one more. This is a tornadic storm west of Norman that you're looking at. So at this time we had a tornado on the ground. See it right there? There's a hook echo, and the problem is the storm is in the cone of silence, but the hook shape is like that. And this is a debris cloud right here. This is going to be around 60th or 72nd Street Northwest in Oklahoma. Now let's look at the spectrum width. Well, we can't see it too well. There's a little bit of range folding, but on a lot of these situations you can pick out the debris cloud very well. And now the storm relative velocity, you see that? This is a better example compared to the Arlington event. Very tight rotation. We have 77 knots inbound, 35 outbound. I'll balance that out a little bit. Okay, 4468. This is about 110 degrees of very tight rotation across a quarter of a mile. This is what we would call gate-to-gate shear. Or in the old days, they would call that gate-to-gate shear. They're trying to do away a little bit with that terminology because it's a little bit misleading with this very, very fine radar quality that we have nowadays. But the principle is still the same, very tight rotation across some gates that are very close together. So this is a tornadic velocity couplet, much different from the meso couplet that you would see at higher levels, like up at 1.8 or 2.4. See, now the circulation is a lot wider. This is up at about 18,000 feet. We would need to see other scans, really. So we'll bring this up to 2246. Very fast moving storm. I should probably bring that to 2242. Well, somehow this has become a storm school. I'm going to get back to the live data shortly. Sorry about that, but some neat stuff to look at that we're not seeing today. That may be a blessing in disguise. But there's the debris cloud. The tornado is going over Lake Thunderbird right there. The main forward flank downdraft right there. So look at that. It's like the hook echo is not really filled in. That can kind of catch you unawares. And there's a new tornado circulation down here that ended up moving to the northeast, and that is what damaged the Country Boy supermarket. It was completely demolished, and they had to rebuild that. So that's coming together right there. Spectrum width, still not showing up too well, actually. And I'm going to pull up some multiple products, 2246. That way I don't have to keep loading files. You can just enjoy. Well, I don't want to. That's kind of morbid. So you can, I guess, kind of appreciate what we're looking at here. So there's the debris cloud. It looks more visible on reflectivity than it does on the spectrum width. And then there's the outer debris cloud. This is the Country Boy tornado getting hit. This is the one that affected the neighborhood I lived in, and this produced the majority of the damage. I should let you all know that this is not live data. We're looking at historical data from May 10th of 2010. Anyway, there's the spectrum width debris signature right there, and this can be very important when these debris clouds are embedded within the precip area, because then you can, instead of being obscured by hail and rain, you can go straight to spectrum width and you can find the embedded debris cloud. That's very, very important. Spectrum width, there you go. You can look at that. You can see the two tornado couplets. Kind of memorize that, these couplets that I'm showing you. Memorize that, because this is kind of the way they should look if you have a strong tornado on the ground. This is what you're looking for. It's not obvious, not always this obvious, but when we have a large tornado on the ground, this is what we're looking for. And then there's the other couplet right there. So two strong couplets. What happens on the next frame, and then we'll get back to the live data. Again, this is not live data. Well, 6 minutes have elapsed. A whole lot has happened. 4 minutes, and you can see that the couplet here moved all the way to here. And we don't know what happened with the other couplet. This is the reason why higher time resolution is going to be very important. As part of the replacement radar for NEXRAD, going ahead to the year 2030 to 2040, they're looking at deploying these very cheap radars on cell phone towers that have very high temporal resolution. We're talking like maybe 1 or 2 minutes. And there would be a lot of those, and with that kind of coverage we'd really be able to focus on what's happening as far as minute to minute changes in the storm. So that's a technology we may be looking at soon. Well, 2030 is not soon, but in the near future, that's probably what we're going to be looking at. So anyway, finishing off the historical situation I'm showing you, this is up at 1,000 feet. Looks like we lose a lot of the resolution of the radar, but as you get to higher tilts, you can see the meso aloft. Then as you go to lower tilts, you see more of the tornado circulation. Okay, so there's the meso. See that right there, very broad meso. couplet to couplet, or across the couplet, we're looking at about 2 miles on that. But with the tornado circulation itself, much smaller scale. Let me set a marker. That would be only 0.3 miles. Of course, on the big wedge tornadoes, that'll be a little bigger, probably on the scale of a mile or so. Okay, let's go back to the live data. Actually, live data is going to be brought in by our start storm polling feature up at the top. So now we're bringing in live data again. Going to get reacquainted with what's happening in the Frederick area and in northwest Texas. Okay, these level 2 data sets are, they, like I said, they're a couple of megs, so it's going to take a minute for those to come up. In fact, let's just now got it. So fortunately, nothing in the Oklahoma City area. It's like a little isolated storm there in Chickasha. Okay, we're at 0.9. We're still a ways from these storms down here, so really we need to be looking at the Enid and Frederick radar, and possibly Dias. So it looks like down by Haskell, it looks like one cell has squeaked out a little tornado warning, and that's going to be radar indicated. So that'll be something else to watch as these storms come together. And remember that cold front is blasting eastward, and that's going to be a factor as it catches up with these storms. You may actually be seeing that right through here around Mangum and up to Clinton. So let's pull up the Frederick radar. While we do that, we'll check out the satellite data. Looks like a mess there. A lot of activity going on. But you can kind of use this to kind of narrow down exactly what cells you want to be looking at. It's like a pretty good cell there near Gage and Woodward. But the tail end cell on the Kansas stuff is all the way down in the Wichita area. Tail end storm on the southwest Oklahoma stuff is in Frederick, so that's where we need to be looking. And the tail end stuff down in Texas is, well, we got one strong cell there with that tornado warning there near Seymour. And then probably some more activity going on there near Sweetwater. So a lot of stuff going on right now. And the cold front is pushed all the way into southwest Oklahoma. Let's see if our 6 p.m. data has come in from Texas Tech. Not yet. All right, so that's probably about the extent of satellite is not as useful anymore because we're almost completely looking at anvils. So the overshoots, looking at those kind of keys you in onto what cells are good, but the radar really makes up for a lot of that. So I think that's probably the last of the satellite data we're going to be looking at for a while. Okay, don't have any new plots, so we're back to the radar. Got our Frederick radar in. You can see our Snyder cell has moved off to the northeast, and there it is right there. Storm relative velocity, we need to set that, change that again because I messed with it looking at the Norman stuff. It seems to work better with slower vectors. Okay, so You can see that looks nothing like what we had with the tornadic case studies I was showing you. No tight couplets up and down the line. There's something here that could be just, yeah, I don't know if that's anything. It probably doesn't have any consistency. Yep, nothing between. Yeah, that doesn't seem to correspond to anything. Okay, so this cell here is looking pretty good. Go on down the line. Let's look at the storm relative velocity. Do we see any strong signatures? No, we see a little bit of strong outbound right there, but these cells, for the most part, they look weak at this time. Probably very outflowish. See that right there, this signature? Any ideas what that is? Can animate that. You can see they don't move very much. That's a wind farm. Those are wind turbines out there. And then our other storm action, this is coming together pretty quickly. They're near Haskell and Stamford. I think it's probably time to look at the Dias radar and see what that's showing. It looks like they did away with that tornado warning. So we're going to pull up the Dias radar and wait for that to come in. I'll see if the 6 p.m. data has come in, and it has not. So it looks like we're gradually shifting into a line for this evening. Very linear cells coming eastward, and that'll be even more the case as that cold front catches up. Okay, we're waiting for the level 2 data sets to come in, and that should be done very shortly. In the meantime, we can check out the warnings. The one north of Abilene is for hail. They're going for half-dollar size and gusty winds. A lot of this is radar indicated. Ping pong ball sized hail and 60-mile-an-hour winds. So there's our MCS forming up. And right there at Haskell is where they had that tornado warning earlier. But you can see these cells, they look very outflowish. See that appearance right there? It's possible we might get into kind of a weak derecho type situation for this afternoon. Or, I'm sorry, this evening. We'll have to watch for that possibility. The main problem that we have, though, is the moisture is kind of on the weak side. We don't... To really have a very strong derecho, we need a lot of instability, and I don't really think we have that for today. Okay, what we're going to look at is storm relative velocity, and we're going to look for strong signatures. You can see that, remember the radar is down here. So as we look at this appearance, we have to keep in mind the radar side is to the southeast. So it's divided pretty cleanly into an area of outflow, or I'm sorry, outbound velocities, and an area of inbound velocities. And the reason for that is it's because we have a linear system. So on one side, out to the east, we have inflow into those storms, showing up as outbound velocities. Then on the other side, we have outflow, which is showing up as inbound velocities. It's kind of like a big battleground here. Do we see that in spectrum width? Yeah, we do. Check that out. So you can use spectrum width to kind of pin down where your outflow boundaries are and see if they're running ahead of the storm very quickly. Would be kind of neat to kind of overlay this sliver on the reflectivity. But see, it's telling us one very important bit of information, that these storms are outflow dominant. See, these are miles ahead of the storms. Like right here. See the spectrum width? See, I put this mark right here. This is about 5 miles ahead of the cores. And it seems to be the case for most of the line, except we saw it briefly there around Haskell, where you saw it kind of curving into the line. So that was probably associated with that meso that we're showing right there. But it looks like that's kind of gone away or filled in. You can see a little bit of it left right there. However, it looks like it's being undercut. See that, how that's kind of filling in. And the velocity kind of bears that out. It's showing that linear appearance kind of filling in like that. So this is what we call a squeegee squall line, kind of moving eastward and sucking up all the moisture that there is and kind of forming a very long linear boundary. And so that brings us to the tail end around Abilene down to Blackwell, Bronte, Robert Lee. Looks to be pretty much the same situation down there. The low-level velocity is not showing any very strong couplets. If I go to base velocity, that gives me an idea of the wind flow at the surface. And I don't see anything of interest down there. So just a long squall line, really. That's all that's really going on right now. Nothing interesting right now. The other thing you can do is you can look at higher tilts and kind of see where the stronger storms are. But you have to keep in mind that there's a range factor. If you get way out here and you're looking at these cells here, you have to go to lower tilts to find those, because the radar beam gets higher as you get further from the radar. So as we go to lower tilts, we start picking up the cells that are down here. But if you see one cell standing out with very strong velocities, that can tell you to go down there and check it out. Okay, nothing of interest down there in Texas. And I'm not too sure these cells are doing anything either. Then up out to the west, they're near Mangum to Elk City. That's the cold front moving in. So we'll probably see all this consolidating into a long squall line this evening. I think that's going to be the situation there. Okay, I'm going to switch back to the Frederick radar real quick. We will wait for that to come in and see if we have new surface data, and it appears we do. There's the 6 p.m. data. And I'm also going to want to look at the Oklahoma mesonet. Okay, so here's our Oklahoma mesonet for 6:05 p.m. So the cold front is moving into the second tier of counties in Oklahoma, out towards Sealing, just east of Woodward, but not quite to the Snyder area. Not quite to Frederick either. Okay, so keeping that in mind, I'm going to go to the Texas Tech plot, kind of paint that in. That's going to look something like this. Remember, this data is about 15 to 20 minutes old, so maybe it's going to be a little bit more like that. And then we bring this further south. I guess our cold front is going to be looking a little bit like that. So the cold front is catching up to the dry line, and do we have any dry line left? Nope, it's I think our dry line is gone now. The cold front is our new ruler, so all hail, and that's going to take over our situation for today, for this evening. So we're probably going to be looking at MCS from here on out. So I'm going to expect this to start filling in over the next few hours. And like I said, I think that's going to diminish the severe weather risk a little bit, because it's hard for any cell to compete along that length and actually pull together. But, you know, there's always exceptions, and of course the Weather Service will have to watch that and keep tabs on that. And I think we're probably done for as far as the situation there. Around Snyder, didn't really see any storms really pulling together there. So I'm probably going to go ahead and stop for tonight rather than spend 3 hours talking about a squall line. If anything interesting happens, I'll probably restart the stream, so you're welcome to check the webpage and see if we have a live stream going. And I will keep watching things. Possibly if it starts looking severe coming into the Oklahoma City or DFW area, I will restart the stream. Oklahoma City, we're probably looking at 9 to 10 p.m. for Oklahoma City, and probably midnight for DFW, but I will be up and I'll keep tabs on things. And like I said, if there's anything interesting, we'll restart the stream and see what's going on. So anyway, I appreciate you watching. Please, feel free to leave comments. I haven't really done a good job getting into the YouTube questions because I've been kind of stretched thin between my projects and email and all that, but I'll try to start catching up on the YouTube comments and stuff, so you can post there. And I think that is it. So maybe we'll see you a little later tomorrow. If not, we'll catch you on the next severe weather situation. Thank you for watching.